Now we go to subtopic 5.2, that is logistic regression with one predictor. In a logic model for one predictor, when one predictor actually is X, the property Y, that Y takes the value 1. Okay. The logic model that is given by this equation. Okay. This is in terms of P model. And the probability P that the independence variable Y takes the value of 0. Okay. So the model is given by this equation where this one is for 1 minus P. Okay. And beta 1, beta 2 here are the parameters, and X can be qualitative, can be quantitative. So that to transform the logic model to a linear model, the odds ratio is used. Odds ratio, okay, is abbreviated as OR. Okay, and the formula for odds ratio is given by this equation. The odds ratio is defined as the ratio of the probability of occurrence of a specific event to the probability that this case will not occur. According to Zeleka et al. 2020, it is assumed that if odds ratio greater than 1, then X, okay, stimulate the event to occur. This means that, okay, odds ratio shows how much the probability of 1 in Y, independence variable is Y, increases when X increases by 1 unit, predicted that is X. Okay. While if the OR value is less than 1, then X, this stimulates the occurrence of the event. Means that this value shows us how much the probability of 1 in Y, dependent variable is Y, decreases when the X increases by 1 unit. And if OR value here is equals to 1, then X does not affect the occurrence of the event. By taking the log of the transformation of P, okay, we will get a simple linear model. Means that by taking the log here, means that in this case, the log here is the log base E, that is ln. Okay, remember that OR is equals to P over 1 minus P. So by taking log to OR, log for this case is log base E. So we get this is will be ln P over 1 minus P, and this is actually is the logic P. Okay, and this transformation is called a link function. Okay, in finding the logistic regression for 1x, means that now for one predictor. Okay, so by taking this one, okay, this equation, logic P is equal to ln of P over 1 minus P, and to relate the logic P with regression, okay, and in this case we only have one predictor. Remember that for the regression model, simple linear regression model, that is consists of beta naught plus beta 1x. Okay, beta naught plus beta 1x. By using antilog to this equation, so that we get P over 1 minus P equals to E power of beta naught plus beta 1x. And then by manipulating and modifying this equation, okay, as given here, we can get the logistic regression model will be given by this model. Okay, that is P equals to E power of beta naught plus beta 1x over 1 plus E power of beta naught plus beta 1x. Okay, and remember that this model is known as the logistic regression model. In this logistic regression model, the independent variable x here, okay, this is x, okay, is not linearly related to the probabilities of y, but rather to a non-linear transformation of the probabilities of y. Okay, so that the estimated or fitted logistic regression model for one predictor, that is P hat here, okay, is given by this equation, where B1, okay, and B2 is the estimated parameters. After estimating the parameters of the logistic regression model, the y value can be determined according to the standard forecast principle as shown here. Means that we can estimate the value of y I hat, okay, by using this principle. If I hat greater than 0.5, less than or equals to 1, okay, y I hat will be 1. While if the Pi hat here is greater than 0, less than or equals to 0.5, so the value for y I hat will be 0.